AMD has killed FSR 4 today. It no longer exists. It is branded now as part of FSR Redstone, and it's just called FSR Upscaling (ML) for the machine learning-based version. FSR Redstone, which is sort of launching today, more on that in a second, also includes other features like a machine learning-based frame generation, machine learning-based ray regeneration, and machine learning-based Radiance Caching. However, the Radiance Caching isn't actually launched yet. So the other thing I want to talk about is this when we get, FSR 4 on RDNA 1, 2, or 3? No. And there's no indication that AMD plans on actually releasing that at any point, despite the fact that we had seen the leaked version of a machine learning-based upscaler that did run on RDNA 2 and 3, which I've tested out in previous videos, but again, that is not happening today. So all of the new machine learning-based features are exclusive to RDNA 4 at this time, and there has been no official word of them coming to previous generations, including APUs that are listed as RDNA 3.5. Now, the FSR Upscaling, machine learning based, this is just a rebranding. This is FSR 4. It is not a different or improved upscaler. So it's just rebranded as FSR Upscaling ML, still exclusive to RDNA 4. The older versions of FSR that are not machine learning based, previously some version of FSR 1, 2, 3, 3.1, etc., are now branded as FSR Upscaling (analytical) to distinguish them from machine learning based. Similarly, AMD's previous frame generation is now being called FSR Frame Generation Analytical, and that is still available on all RDNA GPUs. But the frame generation that is now being introduced new today as part of FSR Redstone is AMD FSR Frame Generation (ML), and it is exclusive to RDNA 4. Now, this is really the only new thing for us to test today. More on that in a minute. Now, FSR Ray Regeneration, machine learning based, is still exclusive to RDNA 4, and FSR Radiance Caching, machine learning based, is exclusive to RDNA 4. And it's so exclusive that it's not available in any games yet at this time. So here's the thing. I was hoping to be able to do a big video on testing out all of the huge RDNA, FSR Redstone features. However, Ray Regeneration is still only available in Call of Duty Black Ops 7 and still only in the multiplayer and zombies mode, not even the single player mode, well, campaign, which I guess is co-op campaign, not truly single player. But anyway, the point is, it's still only available in Call of Duty Black Ops 7 in modes where you might not actually use ray tracing. And I've already done a video on that because it was released when Call of Duty Black Ops 7 released. I'll give you some thoughts on that in this video, in case you didn't watch my other videos, but there's no additional games to test. The main thing I wanted at the end of that video was a game to test that actually did global illumination ray traced. Call of Duty Black Ops 7 only does ray traced reflections, so it's kind of limiting how much we can test here. Now, FSR Radiance Caching is not in any games at this time. So as of this December 10th embargo date, to be clear, I'm filming this video a few days ahead of time because I have review access under embargo, so I'm publishing it here. But basically, on December 10th, which is when you're able to watch this video, this is just available on GPUopen.com as part of AMD FSR Redstone SDK for developers to preview as of December 10th. So in other words, it's now out there for developers to preview. Now, does that mean it's not like a final build of it? Maybe, I don't know. But the point is developers can start playing around with it now. And so we should hopefully see it in games in 2026, maybe, but we don't really have any concrete release date for any of that. So again, in summary, of the FSR Redstone features, the upscaling is not being updated, it's just being rebranded and is still exclusive to RDNA 4. Frame Generation does have a new version, which is exclusive to RDNA 4, and this is new for today, and we can actually test that. And FSR Ray Regeneration is new as part of FSR Redstone, but was already out ahead of this official release as part of Call of Duty Black Ops 7, and I've already tested it. And FSR Radiance Caching is not really actually out yet in any games for me to test. So in this video, I will explain what all of these things are. Then I will explain what games they're currently available in. And then I will test what I can, which is the frame generation, and I will refer back to the testing I've already done for Ray Regeneration. So let's make sure we understand what all of these technologies are. So the main idea here is AMD is trying to bring in machine learning into their stuff. Really, it feels like they're playing catch up to a lot of NVIDIA's machine learning based feature set. And given other things we've seen with AMD talking about Project Amethyst, with Sony's Mark Cerny, head of PlayStation stuff, is that, it's very clear that PlayStation 6 is going to want a bunch of machine learning based features. And it seems like AMD is trying to get up to par, ready for that new kind of console generation push. And so that's also coming to all the PC stuff. That seems like where we're at with all of this. Now, these features specifically, the FSR Radiance Caching, and to be clear, all of these slides are coming from a press deck that AMD made available to reviewers ahead of the embargo date for this video. So Radiance Caching, we don't have this yet. I cannot test this for you in this video, but what is it? This is real-time neural network-based Radiance Caching designed to accelerate ray tracing and reduce Radiance cache time. It's available for developers to look at now. They're saying it's coming to games in 2026. We can't really test this in this video, but the idea is it should make ray tracing more performant, but we have yet to actually see that. They are basically talking about what this is, how it works, how it's trained, etc. Cool. Again, the idea is to make ray tracing better, but we don't have it yet, so I'm not going to make a big deal about that. Again, they're giving some more slides on that. Now, FSR Ray Regeneration, remember we do have right now in Call of Duty Black Ops 7. They say more titles are coming soon. They say it helps to deliver realistic lighting and reflections. In Call of Duty Black Ops 7, we can only test out the reflections, not the lighting, because there's no global illumination or other ray traced features in Call of Duty Black Ops 7. It is a neural network-based denoiser for ray and path tracing. And so basically the idea is you don't run a ray for every single pixel on your screen, so there's going to be some noise in the image. This will denoise that to make it look better. So this is their description of that. You take your source, which again has some noise. You take normals, depth, diffuse, specular, radiance, optional light, visibility, etc. You run it through your machine learning-based magic, and you get a denoised scene. The idea is for it to look better than the source image, and that's the general idea. Now, in my testing in Call of Duty Black Ops 7, to be clear, this slide is from AMD, I agree that it looks better than the denoisers that Call of Duty has built in by default, but I did not think it looked as good as NVIDIA's ray reconstruction, to be clear. But I do think it looked good, just not as good as ray reconstruction, but did look better than the built-in denoisers that the game had that were not machine learning based. That's the summary of my thoughts on that, and I've already done some videos on that topic. I can link them in the video description. Now, AMD FSR Upscaling, to be clear, is just FSR 4, at least the machine learning based bit that is part of FSR Redstone. Now, the idea here is we've already tested this out. I think it's very good. I think it is almost as good as DLSS 4's new transformer model. I think it is better than the old CNN models of DLSS. It's kind of in between, and it's extremely usable. I think they've done a really good job with this, still exclusive to RDNA 4. I was hopeful that we might see some expansion of that here with some version, but we didn't get that. Now, what games support this? So FSR 4, when it launched, my biggest hold up on it was its lack of game support. Since launch, it is now available in way more games. Pretty much anything that has at least FSR 3.1 in it, and then you enable it through a driver override feature. So this is now the list of games that support FSR 4, either natively or through the driver override. The vast majority of these are through the driver override. So that is quite a bit. It's expanded significantly, and I think that's great. It's still not caught up to how many games have DLSS 4, but it is expanding rapidly, and I've talked in my channel about Optiscaler, which is a way to mod it into games that don't support it, although the caveat there is you don't want to do that in games with anti-cheat since you're modifying game files. Remember, you enable this through a driver toggle, which again, only RDNA 4 users will have, where you can enable that override unless the game just has it integrated natively, in which case you just use it through the game menus like normal. Now, the next feature is the FSR Frame Generation, where there is now a machine learning-based version. Now, this is, they're claiming it'll be in 30-plus games by the end of the year. So notice that is significantly fewer games than the FSR Upscaling machine learning, formerly known as FSR 4 Upscaler, because to do this through a driver override, which again is how you do it. So notice that now, instead of just having the FSR upscaling driver level toggle, you now have an FSR frame generation driver level toggle. And to be clear, this is not AFMF driver level frame generation. This is taking games that have FSR frame generation built into the game, and it is upgrading it to the new machine learning based version. But the caveat is it needs to be FSR 3.1.4 or newer in order to have this driver toggle upgrade work. Whereas the FSR upscaling machine learning based upgrade only requires FSR 3.1, not 3.1.4. So because of that, the list of games that are supported is much smaller. So this is the list of games that AMD is confirming have FSR 3.1.4 or higher or natively integrated and are compatible with the machine learning based FSR frame generation driver upgrade feature as of the December 10th release of this video. So that's it. It's not nothing, but it's certainly not as big of a list as what we have for the upscaling feature. Now, for me, upscaling is a much bigger deal, and I use it much more frequently than I use frame generation, since frame generation has latency and image quality penalties that I feel are more noticeable than upscaling, because upscaling actually improves performance. It doesn't harm latency. And the FSR 4, formerly FSR 4, now FSR Upscaling ML, is very good. So anyway, there's that. Now, this is the main thing that we can test out in this video that's an actually new thing to test. Now, they're saying that this has been neural network trained on the most demanding scenarios. It should reduce temporal artifacts for more stable image and improve detail retention in areas with shadows. Again, they're promising 30-plus games by the end of the year. They talk about how it works. The idea is you do have to buffer a frame and use the previous frame, as well as some depth and motion vectors, to then apply your machine learning-based algorithm and then predict what would happen in between these two frames, and that generates your frame. So just like usual, there is a latency penalty because you're having to buffer the current frame before displaying it to display the generated frame, which sequentially happens in between these frames. So you generate a frame that goes in here rather than displaying the current frame. So that's why frame generation has a latency penalty. Now, they're giving screenshots like this, where they're comparing their previous version of frame generation to the new machine learning-based version of frame generation. And when you look at it initially, you might see like, okay, they look pretty similar. But if you look at it a little bit closer at things like shadows and all that, you can tell that the Redstone is doing a better job of not like ghosting and doubling things to the extent that this one is. So again, you can look at things here. They're highlighting here. You can see that this is kind of doubling up some of the shadows and things like that that shouldn't be. And you can see that here those are looking solid. So that's the idea. And this is really the only thing that we can test in the video. Now, one thing they don't mention is whether you generate as many frames as you did with FSR 3.1 frame generation, the analytical-based one, because one thing I'd noticed when I was comparing FSR frame generation against DLSS frame generation is that FSR frame generation, again, the previous analytical version, did generate more frames than NVIDIA's machine learning-based frame generation. And I'm curious if that is still the case when we were looking at AMD's machine learning-based frame generation. In other words, will the frame rate be as high on the new version? And that remains for us to test. Now, when they say FSR Redstone is in 200 plus games, keep in mind that if any of the Redstone features, including just having the ability to apply the machine learning-based upscaler through the driver toggle because you had FSR 3.1 in it, they're counting that, right? So do keep that in mind. Anyway, that's pretty much it. They give a bunch of performance claims, but again, that's mixing frame generation with upscaling and all of that. So, I think at this point, we want to go ahead and actually test this stuff out. So, I am now going to hop into a game with machine learning-based frame generation, and we'll do some benchmarks and image quality tests with side-by-sides. All right, let's test out the frame generation. Now, there's two things to test here. One is going to be the performance, meaning is it generating as many frames as the older analytic version did, or more, or fewer? And then there's also image quality. I want to start out with the image quality, which is what we're looking at here. On the left-hand side of the screen, you see the older analytical version of frame generation. And on the right-hand side of the screen, we see the newer machine learning-based version. All this footage is captured on a 9070 XT. This is the Monster Hunter Wilds version, and I'm on a high-end PC, 9800X 3D, etc. But really the point here isn't the performance numbers. What we're looking for is image quality. Now, in a slow-moving scene like this, you're not really going to see many differences because it's easy for both versions of frame generation. Frame generation struggles more if there's a larger difference between the two frames that it's interpolating. It's trying to guess what happened in between. This happens when you're running at a faster pace. So the reason I selected this intro section is because I know as soon as they get on the dog sled, we're going to have a lot of fast motion, but also I don't need to control the camera. So it's going to be identical footage on both sides of the screen. So that's the idea here. Also, I can shrink myself down. I'm tiny now, so I'm not blocking so much of the screen. And then I could move myself around and point out any differences. But like I said, slow movement right now, I'm not noticing a lot of issues with either of them. I'm not seeing a lot of differences because both are looking very good. So let's go ahead and jump forward in the footage to where he actually gets on the dog sled and starts moving quickly. And I instantly notice some issues on the left-hand side of the screen. Now, I'm not saying the older version was terrible. I think it's completely usable. But I want to go back to where I said I instantly noticed some issues. And I want to see if you're going to notice the same things that I do. As soon as he starts moving, I start to notice issues trailing the cloak on the left-hand side. So I'm basically looking down in this area. So kind of look down here near where I've moved my camera. And let's play this forward again a little bit. Do you notice that there's a weird trailing bit behind his cloak in this area? That's not supposed to be here. Now, one thing we can do is go frame by frame, not because that's how gameplay works, but because it's going to allow us to more carefully analyze the differences in what we're seeing. So I can move forward frame by frame, and you'll see this, if we're looking at the left-hand side of the screen right now, this is a real frame, or in other words, this is not the generated frame. If I move forward one, we're now seeing a generated frame. And you can see that this is having some difficulties right here because it should just be snow, but I think it's thinking that some of this dark cloak should be here. And so it's adding this little smudge that shouldn't be here. Now, it's not that the right-hand side of the screen is doing perfect, because I think some of this like foliage stuff is maybe breaking up a little more than it should be, but I'm not getting that big issue with the cloak that we're seeing on the left-hand side of the screen. And watch how consistent this is if I start just going frame by frame, where you'll see there's that weird smudge on the bottom left, now it's gone. Weird smudge on the bottom left, now it's gone. Weird, not so much in this one. Okay, there's a weird smudge on the bottom left, now it's gone. Weird smudge on the bottom left, now it's gone. Are you guys seeing it? But on the right-hand side of the screen, we're not seeing so much of that. So let's go kind of frame by frame between the two. And again, you're kind of comparing this area of the screen to this area of the screen and noticing that the one over here is looking a lot cleaner on those differences. So in other words, is the machine learning based frame generation doing a better job here? I would say yes. It's not having as noticeable of artifacts. Now, the smudge on the cloak is not the only thing I'm noticing. I'm also noticing, like the smudge on the snow shouldn't be here, but also if you look at the edge of the cloak, I'm noticing some whiteness from the snow that I actually don't think should be blending with the edge of the cloak here. And I think on this side, it's doing a better job of keeping the cloak solid without some of the snow blending in that shouldn't be, and the snow white without the cloak bleeding in with a weird kind of image artifact, right? Again, we'll go forward and backward through these. And again, it's cycling because we're at 60 FPS capture here. That's VSync locked, so one frame is interpolated, the next one is not. And you can kind of get those direct comparisons. Now, I'm not saying the right-hand side is perfect. Like you can tell right now, this is one of the non-generated frames, the actually rendered frames, and you can see that this foliage looks very sharp. But when I go to the next frame, you can see that it definitely looks a little bit more blurred, a little bit less stable. And then when I go to the next frame, it's back to looking sharper again. So, in other words, what am I getting at here? Frame generation, even the machine learning based one, isn't perfect. There are image quality artifacts. However, I'm definitely noticing that in fast motion, the machine learning based version is showing fewer and less noticeable artifacts than the older analytical version. So again, if we play this in actual full speed, you're going to see that actually both sides of the screen look reasonably okay, but there is image quality issues on both, especially when you look at those kind of edges of things as it's moving quickly across the screen. But again, this is full speed footage. Also, I'll mention that I'm giving it a worst case scenario because in order to capture this properly for a 60 FPS video, and also to accentuate any differences between the two, this is generating frames from 30 FPS to 60 FPS. AMD recommends having a baseline of 60 FPS and then going to like 120. So I'm giving this a worst case scenario so that we can accentuate the differences between the two. In other words, think of this as a stress test. But even in this stress test, when I play it at full speed, like both sides of the screen look okay, right? There's not super egregious problems or anything like that. So I will say that image quality wise, I'm certainly going to give the win to the machine learning based version. But like the older version was pretty usable as well. Now, that's not the only aspect of frame generation that we need to test though. So the next thing that we're going to look at is performance, meaning which one is generating more frames or is it about the same? So let's take a look at that using Cyberpunk's built-in benchmark tool. Now, for performance measurement, I'm intentionally not showing you the video footage. The reason is if you capture footage that is not in sync with the capture frame rate, so in this case for a 60 FPS YouTube video capturing 60 FPS of 60 FPS VSync locked footage, then it can introduce screen tearing, so I didn't want people to get confused about what's a screen tearing artifact due to capturing versus the frame generation. So what we have on the left here is Cyberpunk's built-in benchmark running at 4K ultra settings, again on the 9070 XT, and at native resolution here, it's just the native TAA. and it's at about 62 frames per second. Now, this is the analytical frame generation. Again, I'm not using any upscaling. It's just frame generation on top of the native Ultra TAA. And I'm getting about 107 frames per second. And then the machine learning based frame generation is coming out at about 110 frames per second. So the main takeaway from here is that it's a very, very small performance difference. And the small difference that I measured here is in favor of the machine learning based version. Now, I was trying to think like, I almost expected it to be slower because maybe it's doing more. But then I realized actually, if the analytical version is running on the shader cores, which are also just trying to render the game, whereas maybe the machine learning version is running on more of separate machine learning based hardware. I'm actually not quite sure how that might be working out, but that's just a thought process. The point is, overall, the performance number is about the same. So at least in this test, it indicates that any kind of frame rate boost you got from the analytical version seems to be similar on the machine learning based version. And in our God of War footage, we concluded that the machine learning based version looks better. So it seems like performance stays about the same and the image quality improves. Although I will say this is hardly like testing every game out there under every circumstance, etc. So I'm excited to take a look at other footage from other people. I'm sure we'll be testing this out in detail and see if they see anything that I didn't. But in my testing, looks like generates about as many frames as the old version while looking better, and that's good stuff. So let's wrap up the video with the final conclusions. So final thoughts, where are we at with FSR Redstone? Again, this is a suite of features, and the biggest thing is that they're not all out yet. We still need to see Radiance Caching in an actual game. Ray Regeneration is only available in Call of Duty Black Ops 7, and that only features ray-traced reflections. Now, that being said, in my testing of the default denoiser versus ray regeneration, this reflection looks noticeably sharper with ray regeneration. So it's doing better than the default denoiser in the game and at not much, if any, hit to the overall performance. So what we're seeing so far of ray regeneration looks promising, but I need to see how it does with like ray traced global illumination, how it does in other games. And when you compare it against NVIDIA's version with ray reconstruction, I feel like the reflections we're getting are a little bit nicer. So I think AMD could improve the quality to catch up to that. And again, we've seen ray reconstruction in games with full-on path tracing, global illumination, etc. And we still need to see how AMD stacks up in those situations. How are we doing on the frame generation machine learning version? Well, we just tested that out, and I thought it looked pretty promising. I can see that it looks better than the analytical version, at least in the amount of testing I was able to do for today's video, and did not perform worse. If anything, it performs slightly better in my testing, but it's pretty much a tie. So in other words, gives you better image quality at the same number of generated frames. How are we doing on the upscaling situation? Well, they've just rebranded the FSR 4 that was already out there, but I've already said and tested out thoroughly, and so have other outlets, that FSR 4 is very good. It's not quite at DLSS 4 transformer levels, but it's very good. So basically, where I'm at with this so far is that everything we have so far is very usable. It's improvements over AMD's non-machine learning based versions, and there's still some catching up to do to be on the same level as NVIDIA in both the quality of the product as well as the game support list. Remember, only these games have the machine learning based frame generation at this time. We have more games with the upscaling at this point in time, but still not as many as DLSS 4 transformer model when you allow the driver overrides for on the NVIDIA side as well. But in general, I think these are all steps in the right direction. I think this is positive. The main other negative we can take away is that RDNA 1, 2, 3, and 3.5 users don't get to join in on any of the fun, despite the fact that we've at least seen some kind of a machine learning-based upscaler leak out that does run on RDNA 2 and 3. So it would be nice to have seen something there. Maybe it's still coming in the future. But again, those hardware architectures were not as focused on machine learning acceleration as RDNA 4, so maybe they're just going to be left behind. We'll have to see how it all plays out. Hopefully you found this video useful and or interesting. I know I'm certainly interested in seeing what other content creators have been able to do here since, I'm not at the embargo data this time, so I'll be watching some of these along with you, see if anybody else picked up on anything. I'm curious on your thoughts in the comment section, and I hope all of you have an excellent day.